This stuff that we're going to talk about today is also kind of easy. If I gave you a sequence of numbers like this, what do you notice? Going up by 3, right? You're basically adding 3, yes? This is an example of what we call arithmetic sequences. Now, some people in this building as well would call these arithmetic sequences. I think arithmetic sounds a little bit more, yeah, doesn't it though? It definitely sounds smarter. It sounds more sophisticated than arithmetic sequences. So I like to say arithmetic because it makes me sound better. Okay, if you want to call it arithmetic sequences, that's fine. I'm not going to, but I like to say arithmetic. What do you think, first off, a sequence of numbers is? Yeah, it really is, just a set of numbers. That a lot of times are in a what? What do you notice about this particular sequence of numbers? There's a pattern, right? Now, arithmetic sequences are very, very specific types of sequences. What's the only way you can get from one term to the next? Add. Now, can you then have a sequence of numbers that goes like this? Would this be an arithmetic sequence? What's the pattern? It's going down by 3. Most people would say we are subtracting 3, right? I said arithmetic sequences you can only add, right? Is this an arithmetic sequence? Yes. Because what are we adding? Are you allowed to add negative numbers? Sure. Are we kind of basically subtracting? Yeah. But an arithmetic sequence basically is a sequence where the difference between, the gap, what is the gap from one term to the next? 3, right? That gap is remaining constant. If that gap is not remaining constant, it's not an arithmetic sequence. It's some other type of sequence. How many different types of sequences do you think are out there? There's lots of them, right? There's geometric sequences. There's Fibonacci sequences. There's all kinds of different sequences out there, right? Anybody see this pattern? One, 1, 2, 3, 5, 8, 13, 21. So 3 times 3 is 5. That's not gonna work. Anybody see this sequence? This is a very special sequence. What's 1 plus 1? What's 1 plus 2? What's 2 plus 3? 3 plus 5. What's the next number? What's the next number in this sequence? 34. 55. This is called the Fibonacci sequence. This is a very famous sequence. Is this an arithmetic sequence? No. This is a very special one. It does have some cool characteristics and it has some cool uses. But today we are only talking about arithmetic sequences. Okay? No, they can add different terms. Now, in arithmetic sequences, we have to first have some terminology. Okay? We have to be able to basically write these sequences. We're going to call these A sub n. Okay? Now, A is going to just kind of be like kind of the name. N is basically the terms. So the way we write this is A sub 1, A sub 2, A sub 3, A sub 4, and so on and so on, all the way to A sub n. What do you think all of these numbers, the 1, the 2, the 3, the 4, stand for? Will that tell us? That is, what term is it? A sub 1 would be the first term in the sequence. A sub 2 would be the second term. A sub 3 would be the third and fourth, and so on and so on and so on. N would just be like the last term. However many terms there are in this sequence, that's the last one. So, for example, I might give you a problem where I say I have a auditorium, okay? Or I have a music hall, basically, or a theater. And there are 12 seats in the first row. And then there are 14 seats in the next row. And then there are 16 seats in the next row, because basically they just keep adding another seat on each side, right? And that goes on. And there are 50 rows in this auditorium or this theater. My question is, how many seats are there in the last row? Just in A sub 50. Now, there's going to be two different ways we can find this. The first way, what would be the long way of doing this? We could write out every single row. But in order to find the 50th row, what would I have to be able to find? The 49th row. And before I can find the 49th row, I got to know the 48th row, and so on. Basically, I got to know all the rows, don't I? Isn't that going to take a while? So what we want to be able to do is we want to be able to say, let's find a faster way of doing this. So I'm going to come back to this problem. Well, let's just use this one as an example. So what's A sub 1? A sub 1 we said was, how many was in the first? 12? Okay. How did I get A sub 2? I added 2. I took that first term and I added 2, right? How did I get the third term? I took that term, which was 12 plus 2, and I did what to that? I added another 2, didn't I? How did I get A sub 4? I took this and I added another 2, right? What would A sub 5 be? What would be a faster way of finding A sub 5? I'm going to take that 12. How many 2's am I going to add to it? 4 2's. Agreed? Now, I want to figure out the 50th term. That's what I'm showing you right now. How could I find the 50th term? If I kept this pattern going, I need this, don't I? I need the 2's. How many 2's? How do you know it's 49?
Because I'm looking at A5 and I have 4.
Yeah, how many 2's were in the first one? None. How many 2's were in the second term? 1. In the third term, there was 2. Basically, here's how you can calculate these very quickly. You can, to find any term you want. What was the 12? Where did the 12 come from? That was the first term, right? I need the first term. The 2. What is the 2 here? We call that D. That's what we call the common difference. Basically, it's the number we're going up by, right? We're going up by 2, we're going up by 2, we're going up by 2. There's a gap of 2 in this scenario. There's a gap of 2 between every single number, right? We're going up by 2, so we're going to add 2. And then the question becomes, how many of those 2's, or how many, in this case, of, stop doing that, pen. How many of those do I need to add? What do I need to, we said it was 49. How did you get that 49?
Well, because I just looked at 8, 5.
It's whatever that number is, one less. So how many of those, what do I have to multiply that D by? Whatever that number is, the N, minus 1. This little formula will let us calculate any term we want really fast. And I don't have to find the 49th term and the 48th term and the 47th term. All I have to do is figure out what the first term is. I know that. Figure out what we're going up by. Know that. And then multiply that by 1 less than whatever number of term I'm trying to find. So in this scenario, let's say instead of 50 rows, there's 250 rows. How would I find A sub 250? 12 plus 2 times 249. And I don't have to calculate every single one. I can just grab a calculator and figure out what, come on, pen, you can do this. I would do 2 times 249, get that number first, and then just add 12 to it. And I know there's 510 seats in that last row. Simple, right? Arithmetic sequences are very, very simple. Now, once you know this formula, A sub n equals the first term plus the common difference times n minus 1. What that allows us to do is not just simply find like the last term, but it also, if I knew, let's say, I know that there's 16 seats in the first row. Okay? I also know that there are 242 seats in the last row. And I know they're going up by 2. What do I not know? I don't know how many rows there are, right? I can use that same formula, A sub n equals A sub 1 plus D times n minus 1, and I can find how many rows there are. Do I know what the last term is? What is the last term in this scenario? 242? Okay. Do I know the first term? 16. Do I know what it's going up by? Do I know n? N is the number of terms. No. But I can solve this algebraic equation. All I have to do is, what are most people going to do here with that 2? Distribute. All right, so I got 242 equals 16 plus, that'd be 2n minus 2. I can combine my like terms, and I got 2n plus 14 equals that 242. What's the only thing I have to do? Minus 14 and divide by 2. And I can grab a calculator real easy. And all I have to do is get a pen that works. 242 minus the 14. Divide that by 2. And I would know that there'd be 114 rows in that scenario. Right? So I can use it to solve for other things as well. Everybody look at 275. 275. Arithmetic sequences are pretty easy if you know this formula and you know how it works and you know what an arithmetic sequence is. Okay? So if you're looking at page 275, look at number 2. First off, yes or no, is that or is that not an arithmetic sequence? Yes? If it is, what's the D? What is the common difference? What are we doing? Adding 6. Okay, so that one, yes, it is. It's 6. How about number 3? Yes or no? It's going down. Are we allowed to go down? So that just means our D value is going to be negative. What are we subtracting each time? How do you get from a 2.1 to a 1.4 to a 0.7 to a 0? How do you get from a 0.7 to a 0? You're subtracting. So your D value would be negative 0.7. How about number 4? Not arithmetic? Not arithmetic. Because the common difference is not. How about number 5? Going from a 0.1 to a 0.3 to a 0.9 to a 2.7. Arithmetic? No. Easy? Okay. How would I do number 6? They give us the pattern 3, 8, 13, 18. Come on. 3, 8, 13, 18. And what do they want us to find? The 21st term. Basically, they want us to find a sub 21. How am I going to find a sub 21? That formula. What is the formula? A sub n equals a sub 1 plus d times n minus 1. What's a sub 1 in this scenario? 3. Plus, what's the d value? 5, because I'm going up by 5 each time, right? Times, what's n minus 1 going to be? 20, because I'm finding the 21st term, and I go 20. So all I have to do, 5 times 20 is 100. 100 plus 3, the answer is a sub 21 is 103. Done. Easy peasy? Easy? Okay. What is the real benefit of using the formula? Because a lot of people would sit there and say, if I'm trying to find the 21st term in this sequence, can't I just keep going? Like this one's pretty easy. The next term is 23. The next term is 28. The next term is 33. The next term is 38. Can't I just do that? it's going to take a while, right? Especially if we're finding, if you're trying to find the 7th term, which method would probably be the easiest way? Using the formula or just writing them out? Probably just writing them out. When's the formula really going to be useful? When you're trying to find the 21st term or the 250th term, right? Now all of a sudden that becomes, I don't want to do that. We're listing them all out. It's going to take forever. Is there a faster way? The formula is really useful for, especially if you have to find a bigger term, right? A term down the road quite a bit. Is this stuff pretty easy? If you look at number 16 through 21, how can we find the common difference? If I gave you a pattern that was the easy one of 16, 18, 20, 22, 24, 26, and I just said find the D value, how do you know it's 2? How do you know it's going up by 2? How did you get that answer? You did 18 minus 16, or 20 minus 18, or 22 minus 20, right? You basically can take any term and subtract what? The term before it, right? Now, this one was easy because it's 2. But what if you had to do a question like 17? Now all of a sudden it's a fraction. What do you have to do to find the common difference? Take any term and do what? Take any term and subtract the term before it. You could do 3/4 minus 1/2. You could do 1 minus 3/4. You could do 5/4 minus 1. Any one of those 3 equations will get you to the correct answer. What is the answer here? What is it? 1 what? What's $1 minus 3/4? It's a quarter, right? What's 3/4 minus 1/2? It's a quarter. What's 5/4 minus $1? It's a quarter. Now, I'm going to ask this question. I really, really want your response because my guess is it's going to vary. Of those 3 equations, Noah, which one would you do? Of these 3 equations, which one would you rather do? 1, 2, or 3? 1? You say 2? Anybody say 3? Why? All right, don't like the improper fractions. I like, this one only has 1 fraction. It's 1. I'm subtracting from 1. Can you pick any one you want? Pick an easy one. If you go back to number 3, how many of you were trying to do 2.1 minus 1.4 in your head? How did I do that question? How did I just do number 3? Did I do 2.1 minus 1.4? No, I said what's 0.7 minus 0? Why did I say what's 0.7 minus 0? It's an easier problem, isn't it? Pick the one that's easier. Don't look for just the first one all the time. Now, if you don't know that it's a common difference, if you don't know if it's an arithmetic sequence, yes, you should test them all and make sure it does subtract. But if you know it's an arithmetic sequence, just jump to the end or jump to a different one that makes it an easier problem. Because you know they should all have the same answer. All right, this stuff easy? Okay.